Hey everyone, I'm Michael Hall.
Hello, and I'm Robert Wolf, and you're watching Innovation Coffee, where the coffee's hot and the innovation is hotter. Actually, once again, I'm here drinking a Red Bull, not a coffee. Michael, do you have your coffee?
I don't know. I didn't get a chance to go grab it before the show started.
I'll change this. Innovation forgot my coffee.
I'm right. So if I'm a
Yeah.
little bit slow today, it's because I haven't finished my carafe of caffeine that I usually start my morning with.
Yes, but yeah. So welcome everyone. Thank you for joining us. This is basically a place for developers to congregate and enjoy a pleasant conversation about tech and the great things happening in and around the ARM developer ecosystem. So for those of you watching, we have guests who we bring on every single week at 5 p.m. Thursday UTC, and we will be meeting with two very special guests today. We have David Brown, who is a senior engineer at Linaro, and we have Wilfried. I'm going to try to do this last name, Chauveau. I hope I got it all right. And he is a staff software engineer at ARM. And we are going to be talking about Rust on ARM. So there's a lot of things to unwrap here. We have Rust itself, and then we have maybe a little bit of a history of Rust and how we are now approaching Rust on ARM. So there's lots of stuff that we'll be talking with these industry professionals and experts about. Now, Michael, before we dive in to the episode, maybe we can do a quick little review of last week's episode, which was kind of fun because
that's going to be a meta review because last week's episode was itself a review of all of 2023 for us, right?
Yeah, and so for those of you who didn't get a chance to watch this, Gabriel, I wish I had like a way to move my camera over here real quick just so that you could see Gabe, but there he is. Yeah. So Gabriel, our wizard behind the curtain, the producer of the show, I, and Michael, we for proper English, got on the call and we just talked about everything that happened in 2023, and it was just great. So there was a lot of ad hoc conversations about the exciting things we all experienced. We highlighted all the cool stuff that happened in 2023, and just kind of wrapped all that up into a nice 1 hour long episode. So for those of you who want to go watch that, we'll post that link in the description below. And as a reminder, if you are watching this and you have any questions for our guests, as we are going to be bringing them in just a moment, you can post those in the chat. If you are enjoying the episode, smash that like button and don't forget to subscribe because, as I mentioned earlier, we do go live every single Thursday at 5 p.m. UTC, and we try to make this entertaining and exciting for all of you. So welcome. Michael, what do you think? Do we bring in our guests now?
Yeah, I think so. I'm really excited for these two because we actually had them on a office hours a little while ago where they started talking about Rust, and the conversation, it just got so interesting. I'm like, man, we got to get these guys on Innovation Coffee. They'd be great for this. So I thank you both, David and Wilfried, for agreeing to come on and be our guests today.
Hello. Is that so? That's where this came from. It came from an office hours.
Yeah.
Yep. Well, that's awesome. So, thanks for joining the office hours. Those are hosted every week as well on Tuesdays. So make sure you check that out on Discord. Boom, link below. Wilfried, David, what we like to do when we start these episodes off is kind of to get to know both of you. Now, Wilfried, I've never met you before, and in fact, we work at ARM together, but I have not had the opportunity to meet you. David, you and I go way back. Let's take a chance here real quick to kind of get to know you, your origin story of sorts. Wilfried, starting with you, who are you? What do you do? Maybe share some personal stuff with us if you want. You like skiing? I don't know.
Yeah. Well, you already gave my name. So I started as a software engineer back in the day in France as like in a company building devices for logistics, like basically small devices hidden in trucks, and like working with all this environment. Been there for about 10 years and then moved on to other things. And about 5 years ago, 6 years, maybe, I joined ARM, started working on Embed, and now I'm working on Zephyr. Actually, a bit before joining ARM, I discovered a bit about Rust and starting playing with this and figured, this would be great on microcontroller because, there's lots of benefits for lots of difficulties that we have on microcontrollers that are completely limited by Rust. so yeah, starting tinkering a bit with that, and I also got into 3D printing, so trying to combine the two, and that's kind of what brought me to like more recent years. And maybe like 2 years ago, I started building a keyboard in Rust, and that's now my daily. I can't hear Robert. I see you speaking.
Oh no, sorry. No, you're all good. Yeah, I was talking to myself. Yeah.
Okay, so starting building that, and that's now my daily keyboard with the Rust framework, and in the process, I because in the keyboard I used the chip from Raspberry Pi, I became like contributor of that of the Rust support for this chip. So that's what I mostly do now. My spare time is maintaining, like contributing to this crate, and that's where I have fun.
That's the that RP 2040 chip, right?
That's correct. Yes.
Yeah, you talked to us a bit on office hours about that keyboard of yours and some of the interesting stuff that you can do with it. So that's a really cool project.
Yeah, I had lots of fun with it.
Great. So I guess now, Wilfried, thank you so much for the intro. Appreciate it. Nice to meet you formally. David, you are up, my friend.
All right.
And, let's hear.
So I'm David Brown, and as Robert, you mentioned, we go back quite a ways. I started with ARM at Qualcomm, 28 years ago, just a few years ago, or no, 26. Don't make myself that old yet. And I started there just doing their embedded phone stuff, and then like the last couple of years that I was there was Android came along, and there was a big focus on the Linux kernel on ARM, and so that was kind of my job for quite some time there. 8 years ago, I moved to I came from Qualcomm. I moved to Linaro, where I continued mainly as a security focus on the Linux kernel for about half of the time, and then I started focusing on embedded use of ARM, so like Cortex-M type processors, where the microcontroller instead of the kind of full application type processor. A lot of that focus on Zephyr as an RTOS, as well as MCU Boot, the bootloader. I ported that to Zephyr, and one of the main maintainers of that project. When I start talking about hobbies, it's going to sound really repetitious here. One of my hobbies is 3D printing, and I am designing my own keyboard using firmware I've written myself in Rust, running on an RP 2040. So, as far as, like how I met Wilfried, it was both. So we met at a Zephyr conference when he started working on Zephyr. And then I kind of discovered he was also part of the RP 2040 Rust maintainership, and we started talking about Rust and everything. So kind of have a kind of commonality interest in there. And my keyboard has a lot of different focus than most, but it's been a fun project. Eats up a bunch of.
Are you two collaborating on keyboards, or is this like dueling pianos kind of with keyboards?
I wouldn't say that we're actually. I mean, I've used Wilfried's firmware for reference on how to do some things with the Rust embedded project, and specifically the RP 2040. But for the most part, I think the actual keyboard parts have been kind of independent. It's like building a lightsaber. Every Jedi has to make their own lightsaber from scratch, and I got sucked into this world of, I now have to build my own keyboard from scratch. So,
what is it? You met Gabe out at the Rust Conf, I believe, the conference. Where was that one? The Rust Conf, Albuquerque. Yeah, and did you get a chance? Did you get a chance to see his keyboard by chance? Did he show it to you? I was messaging you on Discord. I was like, David, Gabriel's gonna be out in. Yeah, there it is. Hey, yeah, I saw that out. That went out in London. But I think it's pretty cool. In fact, it's something that I kind of latched on to Gabe with, with his 3D printing skills. He's made a bunch of cool stuff for me in the last several years, 3D printing, and he's a keyboard guy. So he's got a bunch of keyboards behind him in his little showcase whenever we're on calls and stuff. And I always ask him for advice when I'm buying a keyboard. So I think it's very, very cool that you've made Oh, there's yours. All right,
Nice.
nice.
Yeah, it's
Very
all
cool.
blurry, but yeah, same thing. All 3D
We-
printed.
Very
We need-
interesting little keyboards.
Yeah, we need to do a keyboard meetup. That would be pretty cool. Yeah. So, Michael, are we ready to go into that main segment? Because it's Rust on ARM. That's the topic today.
Yeah, I think so. So I know, like, recognizing that neither of you are representatives of Rustlang or the Rust community, but for people who aren't familiar with the language, could you just give us a little bit of background about, like, how did Rust get started? What makes it unique from other kinds of languages that people are familiar with?
Sure. Should I go ahead? Or
Whoever wants to start.
I've been looking into Rust and interested in Rust from well before 1.0 came out. Hopefully I'll get the history right here. It started as kind of an individual project by someone at Mozilla, and it developed. And to summarize the whole thing, it developed a very nice community around it. Basically, the intent initially was to do a safe language without a garbage collector, to be able to do, free memory allocation, deallocation, this kind of thing, automatic, a lot of stuff with pointer safety, borrow checker that we'll get into in a minute, that basically lets you write code without having to worry about bad pointers, dangling pointers, bad references, things that are freed that you are still using, that kind of thing. That's handled it largely at compile time. The Rust people, he came from a background of, I don't know if you've heard of the language called OCaml, which is this ML family language. It's pretty high level, very, very heavily based around a garbage collector, kind of dynamic memory. And kind of the goal was to have that kind of experience of a programming language in a language that's a little bit more bare metal, where you're actually dealing with the hardware. It's grown a lot. They've learned a lot. The initial language looks very little like what we have now. There were a lot of things that were tried and discarded. They developed a very careful RFC process for introducing things into the language. There have been a lot of things there's a lot of things behind the language, beyond just the language, that make it work as a community language. This real commitment to backwards compatibility. The language has editions that come out, and the compiler supports every edition that's been out. So I can write my code with the latest edition code, and I can bring in a crate, which is the unit of modularity that someone else has written that compiles with an older edition of Rust, and they work together just fine. And a lot of issues like that they've kind of worked. There's a lot to share. You get into Rust, you start learning it. The first thing you hit is this thing called the borrow checker. And the first thing it does is it tells you your code is wrong, that you think is perfectly fine. And why can't I pass that pointer there? Why can't I store that pointer somewhere? And it introduces a level. So you have a strongly typed language where you have every variable field identifier has a specific type associated with it. This goes even further, that every value in the language, in the program, has a lifetime associated with it. And the compiler tracks this for you. When you take a reference to somebody, it verifies the lifetimes to make sure, largely at compile time, I'll give that caveat there, that pointer will never point to something that's invalid. And that's kind of in essence. It's resulted in unexpected things. There's a slogan in the Rust community called, great, now I'm forgetting the name of the slogan, about concurrency.
I'm not going to be able to help you there, David.
I was just wondering if I remember it. Because I wanted to say reckless concurrency, but it's definitely not.
It's fearless.
Fearless concurrency. Yes, there's our term. The idea that this borrow checker now actually works really well to, when you have multi-threaded applications, to keep you from sharing things between tasks in ways that are not thread safe. And
nice.
A lot of other stuff. I mean,
So I found it interesting, looking up the history of Rust, and I mean, I do want to eventually get to the point where we're talking about Rust on ARM, but looking at the history here, what is it? The creator, Graydon Hoare, am I saying that right, or Hoare? And the name being derived from or him naming Rust after a hardy or remarkably hardy fungi, which is rust. That he says is over-engineered for survival. So I think you kind of address that, right? Like it's kind of like a language, a robust, hardy language that's over-engineered for survival. So that's pretty cool. Wilfried, was there anything you wanted to add to what David just kind of talked about?
No, not really. It was really good. So
okay. Cool. Well, Michael, I know you have some questions here. I have some questions as well. Would you like to kind of start diving into this?
Yeah, let's dive right into the one that you just started talking about, and that's ARM, Rust on ARM. When did Rust start supporting the ARM architecture?
Ooh, details.
If you know that one.
Good question.
Honestly,
I know it supports it now, but
honestly,
I don't know how long
ask ChatGPT.
Gabe, get on it. Ask ChatGPT.
Because it will likely give you
something wrong.
Rust has several different tiers of support for targets. It was initially kind of an x86 Linux based thing, but the back end of the compiler is built around LLVM, and that gives you most of the platform support or the support for a given processor. I wouldn't say automatically, but it gives you a lot of what's needed right away. That the code generation is a big part of a compiler. But so Linux running on ARM is a what's called a tier 1 target in Rust, which means that every release of Rust will be built, binaries distributed, and tested on that target. I don't remember which tier the Rust embedded falls into, because so the Cortex-M targets aren't able to actually run the Rust toolchain themselves. So you would cross compile to that, which fortunately is something that works really well in both LLVM and the Rust toolchain is quite good at it. You just set what your target is in one place and it just builds for that target. But I don't have exact dates. It's been a while.
So let's go into maybe, I guess, this transition. Wilfried, I want to bring you in here. We talk about like let's kind of talk about the early days and then where we are now. So maybe you can kind of like walk us through like how much easier is it now for developers to code in Rust, and what are the benefits of coding in Rust on ARM versus the early years. I mean, I'm looking at, I did some looking here, right down the Google stream, and you get people asking like, hey, like, what's this? How do I use this cross compiler for Rust? Like, are people now are we now at a stage where you can just, it just works, right? You build on ARM for ARM and it just works. So I'm kind of curious, right? Like developers are out there, people who are watching this, like let's walk them through some resources. Let's get them kind of up to speed in terms of why Rust on ARM is a go-to thing.
So to speak about how easier it is, when I started using Rust, it was in 2016, and at the time, you had to define some JSON file to describe your target and its capabilities, like the size of the pointers and data, etc., and use something, I think it was still under development, like a wrapper around the Rust toolchain that would allow you to cross-compile and build some of the core libraries of Rust to be able to target your microcontroller. Nowadays, it's just a matter of so you typically install Rust using RustUp, which is something that manages your toolchain a bit like I think it's called NVM for Node.js or something like that. So you just RustUp, say that you want to install your toolchain, and then you can add some extra components if you want. but you don't have to. The default one is already complete. You just add your target, so it's literally Rust up target add, and then thumb whatever generation of Cortex-M you have, and then you are ready to go. You can just build your application. So yeah, now it's not even a lot more easier. It's just really super easy to get set up and just build. You don't have to download different packages and make sure your system is properly installed with like include path and so on correctly set up. Don't have to think about all this. You just Rust up.
This is a good point though that you bring up, right? Because when you usually start setting up whatever you're going to be working on, you kind of first focus on getting your development environment in place, right?
Yeah.
Like what IDE are you using? What packages do you need? How do I, get this, and this, the libraries, etc. For Rust, like what does it look like? And we have some questions coming in right now from the chat as well, but we'll get those in a second. What does it look like when you're setting up this developer environment? I mean, I'm on, I'm looking at, I'm looking at what it would take for someone to kind of transition over sorry that I'm rattling on with this question, developer environment, but also what would be some of the main benefits of transitioning over? What are the types of developers that should consider, moving to Rust?
Okay, so for the first part of the question about the setup, I was looking at my .files that I use, when I move to a new machine. I can just run that, and I think installing the Rust environment to be able to build something is something like 3 or 4 commands to run, so that it downloads Rust up, installs the default toolchain, add the target that I need, like typically the one for the RP 2040, and then I'm ready to go to compile and flash something. So that's quite fast. Then if you need to have an IDE, you may have some more things. I'm using NeoVim, so things are already in my .file repository, so everything gets set up as I'm cloning this. So yeah, getting ready to build and run is super fast. Then the second part of the question, I might be too biased to answer that correctly, because for me, everyone should switch to Rust, but that's a bit radical, so I'm not sure.
You said it here. You saw it here first. Wilfried wants everyone to go to Rust.
It might be interesting to address the comment that was just there about is it reasonable to go from Python to Rust that was asked.
Yeah, and there was also another question. So we can actually bottle this up into 2 questions, because Hybrid Robotics also asked, is there a possibility for Arduino code to be replaced with Rust? So this kind of like a two questions, same answer kind of thing.
So as I understand, there is a project working on Rust on Arduino. It kind of depends on what you mean by Arduino, because there are now Arduino targets that are ARM-based, and so that's much simpler. The AVR target is kind of challenging, just because it's an 8-bit processor, and the LLVM
yeah, it is supported. I haven't used it yet, but I know there is an AVR support in Rust as well. But also in Arduino, it depends if you talk about just the hardware part, or if you include also some bits of the software, because Arduino software comes with a quite large ecosystem with some bits of OS and like threading and things like that. I don't think you would have that as straightforward in Rust, because there's some framework to start building with RTOS, but I don't know much about them, because I mostly build stuff, like as I think it's called bare metal application. I don't use an RTOS on the microcontroller. I just use the plain code.
I remember somebody talking to me about a Rust-based RTOS. David, was that you?
It might have been. I mean, at some point, maybe we should finish this topic, especially the Python part, and then maybe move on to the different platforms that Rust is actually running on. When we talk about running on ARM, because it's not. There's like at least 3 different things that we could mean by that. So, should we go ahead and address
Yeah,
the,
yeah, no, please.
Yeah,
Sorry,
Python
Dave.
aspect?
Drive this home, David. Yeah, I mean, like by the way, this is kind of how conversations go when you're at a conference and you're all talking. It's just like, hey, let's close this out. Yeah, I like this.
So the issue is with Python. Well, not the issue. The question about Python moving. So in some sense, there's some similarity between Python and Rust in that they're both programming languages. But there's also a lot of
I like the way you put that.
There's a very different mentality and drive behind the languages. Python is a dynamically typed programming language. It's generally compiled on the fly. I mean, it's not always done that way, but it's generally, compiled to like a bytecode and interpreted. And the emphasis is on what's perceived, at least, as ease of use. With the dynamic typing, you can just kind of call things, you can just try them and that kind of thing. There's no state compile step where you get errors. So someone moving from Python to Rust, probably the first thing they're going to hit is this compile phase that's that's like an annoying grammar school teacher that you have to get past, that you want to run your code, you want to try it, and it doesn't even compile. Eventually, you start to realize that that's actually helping you, that the things that it's yelling at you wouldn't have worked anyway, generally. But there's definitely a frustrating learning curve behind that. Honestly, I would recommend somebody wanting to get started with Rust, especially on embedded, take on some kind of project to learn Rust just as a user space program. Mm-hmm. Write something as not hello world, but not a replacement for an accounting suite. I mean, something in between. I have a piece of software called Rsure, which is it's a Linux-based program that manages and verifies the integrity of files. And it was one of the first big projects I created in Rust. And it was a great way to learn the language in a little bit more comfortable of an environment than an embedded environment. And then there's just a lot of differences. The code is pre-compiled. The code is compiled and then loaded onto the target instead of just, you're loading the source, you are editing the source code on the target, and then you can just run it. That set aside, you have a lot of advantages. It's a compiled language. These things are checked at compile time. There's a lot of errors that you just won't get when you try running your code. And with that will come pretty significant performance increases, both in terms of the amount of memory used by your code as well as the speed of execution. So whether it's worth for someone, you're going to have to evaluate that yourself. I think it's worth. I've seen it posted several times of people who aren't Rust programmers for their day job, who have said that learning Rust made them a better programmer in the other language that they were programming it. You have to learn some of these concepts that you may not have thought too deeply about and why they're the case, whether that other language be C or C++ or Python. So I think it's worth learning and then evaluate whether it's useful. I mean, the MicroPython environment on Arduino is certainly a lot more mature. There's a lot more stuff supported. So you're venturing into a bit of newer technology, newer stuff that people are still just starting to work on when you go into Rust on embedded. Hopefully that answers that.
I think so. Hopefully it answers your question there, Hybrid Robotics. And thank you for all of your questions there. We appreciate that. I'm trying to see some comments in here. We have Mehdi Zadi Electronic, who's just kind of putting in some comments here. I want to say, let me just read some of these out real quick. We developers need to create value with new generations of AI, such as decoding and expanding codes with AI models. I agree. For the most part, I'm trying to find a how this relates to Rust on ARM though. So Mehdi, if you want to join our Discord server, Mehdi, please head on over there and we can address all of we could talk about this for days, right? So bring all of your questions over to Discord and we got you there.
Or if you have any specific questions for our guests about Rust,
yeah,
you can
of
ask
course.
those too.
Yeah. Michael, I know you still have several questions on the docket here, so maybe we can move on to the next one since we hopefully address that one for Dale.
Yeah,
Hybrid robotics.
We've talked about Rust a little bit in the language, and it's got support for the ARM architecture. But beyond just basic support, languages get a big boost from using some specialized instructions to perform like heavy operations in hardware instead of in software. So how does Rust handle that? How as a Rust developer do you call those specific hardware instructions?
So
do you want to go ahead, Wilfried, or should I just give the simple answer?
yeah, so the Rust community, especially the embedded Rust community, came together to build some crates, and like one, for example, is called Cortex-M, and this is where you'd find all those like functions that wraps the instructions that you would need for like special operation, like typically. Thinking like if you need to go to deep sleep and wait for interrupts and things like that, that's where all those functions are defined. And yeah, I don't know if you want to add something, David.
Not really. I mean, in some sense, it's not different than how you would do it in C with LLVM. That there's mechanisms the language gives you for describing intrinsic inline assembly, that kind of thing. Rust has some pretty nice, powerful mechanisms for abstracting that to make it a little bit easier to use without incurring any additional cost in terms of how you use it. Okay,
so you would, if you were just writing, like you would suggest, do an application level project. If you were doing that, you could just use Rust code to call other Rust code that's taking advantage of those optimizations kind of under the hood.
Yeah, for example, if you were using a crypto library that was written in Rust, and I would just be calling these basic operations, and a crypto library would typically have optimizations for a specific core that might have intrinsics for performing parts of these operations. And the details of how that's done, I wouldn't have to be concerned with in order to use this. Probably the most significant level of where I would be concerned is the crate that implements that would probably have feature flags. These are flags that can be passed, enabled and disabled per crate when you bring them in. It would probably have feature flags to define the specific target that you're using, which would affect what code is then compiled in to support that.
Okay.
So should we talk about the kind of different ways that Rust actually runs on ARM?
Let's do it.
Yeah, because I know Wilfried mentioned Cortex-M, and we've talked about Cortex-A. So yeah, what are the different, I guess, classes of ARM hardware that Rust will run on?
I think any of them really. Rust can run everywhere.
Yeah, Rust in the cloud, Rust on your laptop, Rust on your SBC.
Yeah. What do you mean by Rust on USB-C?
Sorry, single board computers, like just Rust on your.
SBC.
Oh yeah.
Oh
yes, definitely. Yeah, it runs on all of them.
I think a simple way to think of this is there's the user space program that runs on Linux is a typical case where we have a Cortex-A that's running Linux. And this is actually, as far as Rust is concerned, not really any different than a desktop machine that you would run or develop Rust on. You could cross-compile to it. You could compile directly on it. And think of something like a Raspberry Pi, not the Pico, the one that's running a Cortex-A. You get a prompt. You're running Debian on there. You can install the Rust toolchain if you desire, or cross-compile, as I mentioned. And you have all of Linux available to you, and the whole library in Rust that is called standard std. Two of the other environments that you would run on, which would be for the Cortex-M, where this processor doesn't actually have the resources to run Linux. One is something known as bare metal, where you are effectively compiling your code without an operating system. And this is done through these support crates. There's several levels of these. There's a hardware abstraction layer, HAL, and then there's a peripheral access control, I think is what that stands for, the PAC
Crate.
That
I think it's great.
or peripheral access crate, perhaps. That's a and generally these are auto-generated from the SVD descriptions that a given SOC will publish that describes all the registers, and this tool then generates this crate that just gives you all of the registers in a Rust safe kind of way, that once you actually have like a register block, it's not necessary to do quote unsafe things in Rust. Mostly it depends on how well they did with it. And then if you need something like a scheduler, multiple threads, interrupt handling, you can do some of that yourself, or there's several different projects that implement schedulers. There's something called Embassy, which is kind of an RTOS in embedded Rust, written with this kind of mindset that it's pretty much bare metal where we'll throw in a scheduler. There's another one called, and I'm not sure how they pronounce it, RTIC or Arctic. And this is a, it's a little bit more, the term I would use is hard real-time focused, that it's a, instead of a general purpose scheduler, it actually schedules your tasks using the interrupt controller on the chip and requires some kind of knowledge of how that works. But the important thing is that you get these as options, that this is a choice you make when you configure your top level cargo file. You pull in the code that you want for the target you're working. So that's Rust embedded. The other world that's just kind of getting started is that you take an RTOS that exists for these microcontrollers that has Rust support, or like in the case of Zephyr, that's an RFC about how to start doing that. And you would write your application having these kind of Rust cleaned up interfaces to the underlying RTOS. As far as Rust goes, there's the standard library is divided into three parts. There's something known as core, which is all of the functionality of the language that is available on any target. So whether that's a deeply embedded target with no allocator, anything like that. There's another crate called alloc, which includes collection type data structures, strings, the kind of things that require a memory allocator. And this can be used in an embedded target by providing an allocator. And there's a crate you pull in that gives you one of these allocators for your embedded target. There's also a crate called standard, which is everything else you'd expect from a standard library. And it, by the way, pulls in the others so you don't have to manage multiple namespaces in your code. Standard includes concepts such as files, networking, all the stuff that's typically available in the standard library of a programming language. And embedded projects take different approaches as to whether they support standard or not. I would say, if anything, the growing trend with alloc separate is to not use standard in an embedded environment and provide things specific to the RTOS. But I don't know if everyone would agree with me on that. I don't know if you had anything to add there.
I suppose that depends a lot on what your target hardware is too, right? Like how
right.
much space you have, how much memory you have.
Right. When you have 128K of RAM, it definitely affects the decisions that you can make.
Yeah.
Yeah. And yes, so I think you alluded to that in Zephyr is with Rust you can also link and call into like regular like C functions. Typically you can, if you have an algorithm that's super optimized for your target and you have that in C, you can just build that into an object file and link that into your Rust application. So you don't have to rewrite everything in Rust. You can use existing things. So if you want to use, so ideally, if you want to use Zephyr as your like RTOS in general, you can build create a little library that does just what you need, and you compile that into an object and also link that into your Zephyr application. So it can go both ways. You don't need to have everything done in Rust. You can interact with others.
Good point. And the Zephyr Rust project specifically, because that's what I'm kind of interested in, is about not just making these functions so that you can call them, but then how do we make what Zephyr provides available in a much friendlier way within Rust, using the abstractions and other things that are available to Rust. So there's kind of multiple levels to where you can support C code, that you can just make it like functions that you call, or it can be, wrapped in things. Sorry about that.
I like it. Is that your ringtone for a particular person
ringtone.
Or for everyone?
That's the general one.
That's the general one. Oh, okay, cool. Nice. Yeah. So, sorry, am I interrupting anyone here?
I just wanted
please.
to add to, you mentioned earlier the embedded HAL. It's actually it was published like the 1.0 version, so like the first stable version of the embedded HAL just recently. I think the crate guide was updated 2 days ago, so that was like a milestone for the embedded Rust community. And this is one of the things that I find really good in Rust compared to like legacy C things. That's because there's like one HAL that's shared by all the ecosystem. So when you build a driver for a peripheral, this can be used by anyone. You don't have to like write some glue code for your specific platform and so on. This is like really generic. And when you are on the other side implementing support for a specific device, you just implement the trace of this HAL, and then you know that people can use any driver with your chip. So it saves a lot of work overall to everyone, from having to write little bits of glue codes everywhere.
That's great. Yeah. So I want to bring things back to I want to say a more higher level, easier level.
Beginner friendly level.
Yeah. So let's assume I'm not a new developer, but new to Rust. I've coded in other languages, again, maybe Python, maybe some C. I'm familiar with certain IDEs. I'm familiar with the libraries I need to include in my code. I'm familiar with compiling. How does this one-to-one correlate or relate to the Rust experience? And I'm not sure if we've already talked about it. I don't think we have, but I kind of want to like, you're about to sit down and code something in Rust. Like, what do your first steps look like? Like, we talked about the developer environment. Now you've set up your developer environment. Now, what do your first steps look like as a developer getting started in Rust?
If you start an application for like a desktop environment, first thing I would do is just cargo new, and you just create a new crate for application, and you start from there. If you're building something for like an embedded device, you typically use something called cargo generate, and then use some GitHub repository that has a template for your project. So this is what basically seeds your application. The difference between the two is mostly because for an embedded target, you need some extra files, like something to describe the memory layout of your target and a few bits and pieces like this. But yeah, overall, it's just cargo new.
And are there any IDEs that you two in particular favor? Let's not get into the Vim versus Nano.
Ask people to ask that question.
Oh no.
I mean, so Wilfried is an NVim user. I'm an Emacs user when it comes to.
So there you go.
There's conflict there.
Not really. I mean, I use Spacemacs, which is Vim commands based on top of Emacs, but neither of those is what I would actually recommend to somebody who's just getting started. I have gone through, say, Visual Studio's support for Rust, and at least for desktop applications, it works really well. For an embedded type of application, there may be some work. I know there is a Cortex M module with that tries to help with the debugging. The challenge with an embedded environment is that you don't have a Linux prompt and a command line. You have to somehow get the code onto the target. You have to talk to it. The Rust embedded project has some pretty good tools that are like command line based, and I don't know the level of the IDE support with this. There's a command called cargo run that you use on the desktop, and in embedded, you can typically type cargo run once it's configured correctly, and it will copy the code and flash it.
Yeah. Actually, I see one of the questions in the chat asking if there's a plugin for VS Code that supports Rust. There is one, definitely. I can't remember its name exactly, but it's typically backed by a tool called Rust Analyzer, which is a language server. That's also what I use in NeoVim. So yes, there is support, and it's something that's used in different environments. It's basically using the same tool behind the scene.
The VS Code plugin for Rust would use the same back end. So the idea is that the support for an IDE is done in a general way, and then each IDE interfaces with that so that they don't have to learn how do you find identifiers in Rust and that kind of thing.
Yes.
So guys, we're getting to kind of like, the last few minutes of this episode, and I feel a little bit overwhelmed in terms of like unpacking this, right? Like, even from preparing for this episode, you search Rust on ARM and you get articles all the way back to 2019. You get things that are outdated, some things that maybe are useful, maybe are not. And so I'm curious, and I would love to provide this in the description of this episode for people who are watching on demand later, or just those who are looking for resources for Rust on ARM. Are there any go-to things that Linaro offers, or that ARM offers for that matter? Are there some good blogs or code repositories that have, technical documentation to get people brought up on this? Because I can imagine people looking to just go like, hey, typing Rust on ARM into Google or how to get started with ARM, you're going to get just flooded with resources. I'm curious if you two have any, resources that are robust and good enough right now to single out and demonstrate or show to our guests. Our viewers. So
start with the Rust book for the general case of Rust, and then there's another one called the Rust Embedded book. Start there.
Okay, so these are just like books, like straight books.
Yeah, they're online.
Gotcha.
I think the Rust book you can actually get in print now, but
it's called the Rust book. Because there's a lot of Rust books. Again, like you go search like Rust book and you get like 100.
There is a thing called the Rust book.
Gotcha.
That's a specific thing. So
perfect. Excellent. So that's a good resource. And what about you, Wilfried? Do you have anything? Does ARM have any resources out there? Any good blogs?
I think there's a few resources on things called ARM Developer Program. Like some.
Oh, are you talking about on the Developer Hub? So I see like tutorials, learning paths.
Yeah,
I think there's a few
install guides I see right now for Rust on ARM on
very nice
our Learning Hub.
So let's make sure we get those into the description. I think that'll be very useful, and that's awesome. Michael, you have any more questions here before we kind of start closing this out?
Yeah, I want to transition away from the technical to the community a little bit, but Hybrid Robotics had another question in the chat that I wanted to give a chance for us to ask, and that was: do you know of any machine learning projects that are using Rust right now?
I don't, but
I'm sure there are.
Sure.
I guess you two focus a little bit more on the embedded side of things than.
I think I've seen. I think it's called TVM. Has some discussions about Rust, but I haven't looked into this in a while, so I don't know what's the status.
Let's address this one then. This one's from Leon, and he says the one thing I've seen is dependency hell, where the dependent libraries don't work on maybe ARM, but hopefully it's getting better.
Probably they require standard is generally the issue that you will run into with libraries in embedded, that because it's not that common to find actual libraries that don't work on like an ARM AH64 target with the regular running on Linux. Things are getting better, but I've actually run into this just with the keyboard stuff. It's like, oh, well, I have a bunch of regex I want to deal with. The regex crate requires standard. I don't have that. I sent a message off to the developer of the crate, and he said, well, there's a light version of the crate, but it's broken. And, I ended up using something that was more targeted. It turns out I got it to work on embedded, and it used 3/4 of my memory the first time I tried to match a regular expression, and just a general regex engine doesn't really work when you have 128K of RAM. So some of them is that kind of case. Other things are work needs to be put into making things work with no standard. I mean, it's definitely a place. It's getting better, but there are indeed a lot of crates that don't do that. As far as the term dependency hell, Cargo, I would say, handles that better than any ecosystem I've ever used. As far as that you have the ability to bring in things as specific versions and specify constraints on them. And in the worst case, where you have two incompatible versions of a library that are needed by different dependencies, Rust is perfectly happy to bring both of those in.
Yeah.
Nice.
Yeah, I think to a certain extent, dependency hell is going to exist anywhere there's dependencies. It's just it's the nature of the beast when you got different people developing different versions at different time frames.
One thing here I do want to bring up and thank Daniel Thompson, one of our ARM ambassadors. And by the way, I did not mention David Brown is also one of our ARM ambassadors here. But Daniel Thompson actually kind of, I think, clarified the question here for Hybrid Robotics, asking about a good plugin for VS Code, Rust Analyzer. So I think that must be the one. If you are on VS Code and you are trying to do this, give it a shot. So thank Daniel for bringing that up.
All right, so I did want to transition this over to talking about the Rust community, because you mentioned at the start that this is a very community focused, community run thing. Can you tell us who's working on the ARM optimizations? Like, give a shout out to the people who are doing that work and contributing that back.
Oh, there's actually a lot of people. So I would just say go on GitHub and check the Rust Embedded organization and look at all the contributors there. And this is only just for the common part of the ecosystem, but there's also all the maintainers and developers contributing to the various chip support crates and drivers. So yeah, that's a lot of people, because there's two organizations on GitHub. One's called Rust Embedded. I think the other one is a Rust Embedded community. Yeah. So that's a lot of people. Like, typically there's a USB stack that's hosted there, and that's the same for everyone. And that's also like a huge thing, because it becomes really trivial to deploy a USB stack on your target. And yeah, so there's lots of people. I couldn't name one specific, or even just a few would be.
I guess that's a good problem to have, though, right?
Yeah.
Too many contributors. Please stop. Yeah. So we just posted the link there in the chat, Rust Embedded. And you said Rust Embedded /community, or was it?
No, it's Rust Embedded -community.
Oh, Rust Embedded -community. I want to see this. Let's see. And it takes you right there. Yeah, Rust Embedded -community. I'll post it here, Gabe. I got it up here already, I think. So for those of you, Rust Embedded -community. I think this is it. Oh, this works. Okay, Gabe, you're gonna have to do it because the copy paste button isn't working on my computer. So go check those out. Now, Michael, does that answer your community questions? I feel like we're kind of pushing the time here.
There are also, yes, I think time to start wrapping things up now.
Yeah. Okay, cool. So this is our shameless plug time. So you've earned it, Wilfried, David, sitting with us for a whole hour. If you have anything you'd like to plug, maybe we start with you, David. Is there anything you'd like to talk about or let us know about, on topic or off topic before we tune out?
Sure thing. So there's actually going to be somebody talking about Rust training at the upcoming Linaro Connect. So there you go. There's a link to that there. Linaro, we do this Connect, currently once a year, with an emphasis on development on ARM, and it's something we're starting to look into. And so there's something there. There's both a kind of as I understand it, there's like a free version, and then there's also like course of training you can actually purchase for that. So
sorry, keep going.
Oh no, that's really all I had to say. So,
and in terms of Linux on ARM, Linaro Connect is like where all the Linux on ARM rock stars are. right? Like, you know, I mean, because I've been to Linaro Connect obviously a dozen times or something. And you know, when they have the opening keynote and they start celebrating all of the contributors to Linux that are working at Linaro, it blows me away to see, you know, people like number one on top contributions, top contributors, top merged pull requests, et cetera, et cetera. Like Linaro takes the cake. These are the all-stars of this space. And I was really happy to see last year Mani Vanan Sadasivam up on that list. He was with the 96 boards program in its day. So David, thank you. Linaro Connect, linaro.org/connect. Check that out. What about for you, Wilfried? Anything you'd like to plug?
Yeah, just if you consider learning Rust and trying on ARM microcontroller, you can check out the RPRS community or like org on GitHub, and yeah, we're nice people, and if you have any question, we'll be happy to answer.
Excellent. Okay.
All right.
Michael.
And if you start doing any Rust programming on ARM, we would love to hear about it. So join our Discord. Let us know what project you're working on. Show us what you're doing. Join us for our office hours. We have 2 office hours a week right now, both on Tuesday. The first one is at 2 p.m. London time for our folks in Europe and Africa. We've also got 2 p.m. New York time for those of us in the Americas. And we will soon be launching one for time zones further out in Asia. So look forward to that as well. So yeah, join our Discord. We're all on there.
Awesome. Great. Well, Michael, do you mind if I close this one out?
Do it.
Okay. Gentlemen, Wilfried, David, it's just been an immense pleasure having you on. Always good to see you, David, my friend. And I wish both of you a wonderful rest of your week. Thank you for spending your time with us. And of course, to my wonderful co-host up here, kitty corner to me, Michael Hall. Thank you as always. Everyone watching, we appreciate your time as well. Thank you for joining us. And if you'd like to see more episodes like this, don't forget to subscribe to the ARM Software Developer YouTube channel. And of course, if you enjoyed this episode, hit that like button. It helps us out a lot. Next week, we will be talking with, and I have it open right here at the top. We will be talking with Bailey Hayes and Liam Randall of Cosmonic. And we're going to be talking about WebAssembly on ARM. So kind of holding on to the theme, we have now Rust on ARM, OpenShift on ARM, optimizing .NET on ARM, and now we'll be going into WebAssembly on ARM. So keeping with the theme, we look forward to seeing you all next week. David, Wilfried, once again, thank you very much. You all have a wonderful time. Michael, take it easy, buddy.
Take care, everyone.
All right. Bye.
Thank you. Bye-bye.